Good afternoon, or actually good evening, ladies and gentlemen. Can anybody hear me?
Yes.
All right, we made it to the end of the week. We're gonna close out the week here by closing out chapter 6. We're gonna look at 6.6 tonight, as we are going to use our factoring skills to solve polynomial equations. Okay, so in section 6.6, we are going to solve polynomial equations using factoring. So that's what we're going to do tonight, section 6.6. Okay. Now, to do so, we need to kind of follow these steps here. Step number 1 is you want to get the equation set equal to 0. So we want to get our equation set equal to 0. Step number 2, we want to then factor completely the non-zero side. Step number 3, we then want to set the variable factors equal to 0. And what justifies us doing this? Justification. There's a theorem in mathematics called a zero product theorem that justifies us in being able to do this. Zero product theorem. It's a pretty intuitive theorem, unlike most of them. It says this: if A times B equals 0, then, ladies and gentlemen, what must be true about A and or B? What do you think would have to be true about A and or B?
Would it be A equals 0 and B equals 0?
Yep. A and or B must be equal to 0. That's true. Kind of makes sense. All right. So this is the theorem that will justify us in setting our variable factors equal to 0. Once we set our variable factors equal to 0, then all we have to do is just solve the simple first degree equations. And we'll have our solutions. Okay. So that's in general how we're going to attack solving higher degree polynomial equations utilizing what's called the factoring method. And obviously, step number 2 is going to require that we know how to factor polynomials. And that's why we went through chapter 6 before we encountered chapter 6.6. There's a reason for that. Okay. So, ladies and gentlemen, our factoring skills are going to get a test tonight again. Hopefully you are continuing to sharpen your factoring skills by doing textbook homework. And I am hoping sincerely that you are checking your answers when you do your textbook homework, as I do post all the solutions. I have a question. Does anybody out there go above and beyond my homework assignments and actually do some of the even problems too for extra practice? Anybody? there's dead silence. Dead silence. Nobody out there goes above and beyond and does any extra practice with some of the even problems. You can always check your answers if you would like. I do post solutions to all your problems, odd and even. And so, there is extra practice available. All you have to do is just invest in it. Bare minimum is I normally assign odd problems, but by all means, if you feel you need some extra practice, ladies and gentlemen, do some extra problems. Do some of the even problems. Check your answers. Okay. All right. Any questions about these steps here? Steps 1 through 4 in solving polynomial equations using factoring. Any questions? If not, we can get going, ladies and gentlemen. So let's begin to solve some polynomial equations using our factorization skills. Okay. All right. Let's see if we can try a relatively simple one first. So the instructions, as you would guess, are going to say solve. All right, so we want to try to solve this second degree equation. Notice this is a second degree equation because we do have a second degree term, x squared. And so we're going to try to solve this equation. Now there is a theorem in algebra, there's a lot of theorems in mathematics, but here's a pretty important one. It's called the fundamental theorem of algebra. And the fundamental theorem of algebra says this: an nth degree polynomial equation will have n solutions. The theorem guarantees this. So, what is the degree of this equation? What is the degree of this equation, ladies and gentlemen?
The second degree?
Second degree. So how many solutions is this thing going to have? How many solutions do you think the second degree equation is going to have by the fundamental theorem of algebra?
Two.
It's going to have 2 solutions. When we get done, we're going to have 2 solutions to this equation, not 1, but 2. And these 2 solutions have to satisfy this equation. Okay. How do we solve this equation for its 2 solutions? Well, we're going to factor by using our factoring technique. We're going to solve this by factoring. Step number 1 is what? We got to make sure that our equation is, first of all, set equal to what? 0. Is our equation set equal to 0? The answer is yes. We're lucky. Step number 2, we got to completely factor this left side now. So we have to factor a trinomial. So ladies and gentlemen, can this trinomial be factored? Now we got to go back deeper into chapter 6 and ask ourselves, can we factor x squared plus 5x plus 6? Notice there's nothing we can factor out of all 3 terms. It's not a 4-term polynomial. It's not a binomial of any kind. It is a trinomial, one with a leading coefficient of 1. To factor these types, we use our product sum method. I need 2 factors that give me a product of 6. And they have to add up to give me a sum of what? What does the sum have to be?
5.
5. Can you think of 2 factors of 6 that add up to 5? 1 and 6, 2 and 3, -1, -6, -2, -3. These are all the factors of positive 6. Which ones add up to positive 5? Only 2 and 3. None of the other ones work. So therefore, this trinomial on the left side of our equation can be factored into what two binomials? What can I factor it into?
X plus 2 and X plus 3.
X plus 2 times X plus 3. The left side of my equation has been completely factored. Now that we have the left side completely factored, we now set the variable factors equal to what? 0. And then we solve the resultant equations. So we set X plus 2 equal to 0. We set X plus 3 equal to 0. We now have two simple first degree equations to solve. Here we subtract 2 from both sides. We get X is equal to -2. Here we minus 3 from both sides and we get X is equal to -3. Ladies and gentlemen, we are done. We have our two solutions, -2 and -3. Those are your solutions. Any questions how we solve that equation using our factoring method? Any questions? Okay. Let's see if we can solve another one. We'll try to solve this equation for M. Now, the first step is we want to make sure that our equation is what? Set equal to 0. Well, it already is. The next step is we now need to completely factor the left side. Good news, ladies and gentlemen. It already is completely factored. Next step is set all your variable factors equal to 0. So the left side already is completely factored. So we set each of these variable factors equal to 0. And then we solve each equation for M. This is the easiest equation you will ever solve in your entire existence. M equals 0, that's already solved. That's one solution. Solving this equation for M, we subtract 4 from both sides. Divide both sides by 3, and another solution walks out of here with the what? A value of -4/3. Solving this equation for M, we add 4 to both sides. We get 3M is equal to 4, divide both sides by 3. And M is equal to what? 4/3. Ladies and gentlemen, we are done. We have our two solutions to that equation, our three solutions. We have 3 solutions. So what degree would this equation be? It would have to be of what degree, since we have 3 solutions?
Third degree.
Third degree. Now it doesn't look like it's third degree, but that's because it's completely factored. If you were to multiply this all back out on the left side, you would have a third degree term in M. M times 3M is 3M squared. 3M squared times 3M is 9M cubed. This is a third degree polynomial equation. That's why we got 3 solutions. And that's guaranteed by the fundamental theorem of algebra. Any questions how we solve that equation? This was a very easy one to solve for many reasons. Number 1, it was already set equal to 0. Number 2, the left side was already completely factored for us. What a luxury, huh? Do you think they're always going to be this easy?
We can hope so.
You can hope so. Just for the record, ladies and gentlemen, I will never give you an exam or quiz that has 30 of these types on it. This one's a nice one. I might slip in a nice one once in a while, but you're not going to have all your questions looking like this. So enjoy that one. Back to reality, though. Let's try to solve this by factoring. So we'll try to solve another one by factoring. All right. So here's a problem here, ladies and gentlemen, and what we want to do is we want to try to solve this equation by factoring. Now, what's the first step? Got to make sure the equation is set equal to 0. Then we got to try to completely factor the non-zero side. So we have to factor this trinomial. I'm going to let you guys do that. Ladies and gentlemen, I want you to factor this left side, and when you get that factored, you tell me what the factorization is. This is not classwork. I mean that you're going to hand in, but just tell me what this would factor into. How does this trinomial factor?
The t would be cubed.
What's that?
The t, that's the 1t squared, and the left hand t will turn into 11t cubed or 10t cubed.
Well, this is a second degree equation. It's t squared minus 11t plus 30. So can this trinomial be factored? Well, product sum method. What does my product have to be?
30,
What does my sum have to be?
negative 11,
I'm looking for a couple of factors of 30. Let's sum up to negative 11. Negative 1 and negative 30. No, these don't even come close. These add up to negative 31. Negative 2 and negative 15. No, these don't work. These add up to negative 17. No good. Negative 3 and 10. No, these add up to negative 13. We're getting closer though. Still no cigar. 4 don't go into 35 does. Negative 5 and negative 6. What do these add up to? Oh, they add up to what we need, ladies and gentlemen, negative 11. Two factors are negative 5 and negative 6. How does this factor now? How does that trinomial factor?
t minus 5, t minus 2.
That's it. So that's factored. Now we're going to set both factors equal to 0. And now we just have two equations to solve for. Solving this equation for t by adding 5 to both sides, we get t is equal to 5. There's one solution. Now this equation by adding 6 to both sides, we get another solution that says t is equal to positive 6. Ladies and gentlemen, we have our two solutions to that equation. What degree is this equation?
Second.
Second degree. Second degree equations have two solutions. Second degree polynomial equations have two solutions. That's your answers. Okay. Done with that one. Try another one. All right, we're going to try to solve this second degree polynomial equation by factoring. We got a trinomial here to factor. Notice there's nothing you can factor out of all three terms. Therefore, we're going to try to factor it as a trinomial. Unfortunately, it's a difficult type of trinomial to factor because it does not have a leading coefficient of 1. And because of that, ladies and gentlemen, we're going to have to use the grouping method. So we kick this off by taking 3 times negative 5, which gives us a product of negative 15. We now are searching for a couple of factors that sum up to the middle coefficient of positive 14. Can you help me out here? Give me a couple factors of negative 15 that add up to 14. Do they exist?
-1 and 15.
All right, -1 and 15. Our factors of -15, and notice these sum what we need, namely 14. We're now going to use these factors to factor this trinomial, this difficult trinomial. We do so by rewriting it as an equivalent 4-term polynomial, where the middle term gets split up and rewritten in the form of -1u plus 15u. Now that I have a 4-term polynomial, I'm going to group together my first and last two terms by placing them inside parentheses. No sign adjustment necessary on the last term because my third term is preceded by a positive sign. What can I factor out of the first two terms?
A u.
A u times what do I leave behind?
3u minus 1.
1. Good. What can I factor out of the last two terms?
5.
5. And what had I better leave behind? I'll give you a hint. Do we leave this behind?
Yeah.
3u minus 1. Good. Now we factor out the what? The common binomial factor of 3u minus 1. It gets factored out. Here it is. Times what remains after doing so?
U plus 5.
U plus 5. U plus 5. That left side has been completely and successfully factored. We now set both factors equal to 0 and then solve our equations. Set 3u minus 1 equal to 0, set u plus 5 equal to 0. Solving this equation for u, we add 1 to both sides, divide both sides by 3. Ladies and gentlemen, we get one solution as being 1/3. Subtracting 5 from both sides, we get u is equal to -5. Ladies and gentlemen, we have our two solutions to that equation. They are 1/3 and -5. Questions how we're solving equations by using the factoring method. Any questions, ladies and gentlemen? Let's see if we can do this next one here. We want to solve this equation for its how many solutions?
2.
2. Step number 1, is my equation set equal to 0? Yes. Step number 2, can we factor the left side completely? Help me factor this left side. What do I do? Anybody? How can I factor this left side?
Can you pull a 5 out?
Aha, thank you. First question we should always ask ourselves is, can we factor anything out of all the terms of the polynomial? That's question number 1 in our toolbox. You know what? I never did post a factoring toolbox, did I? I apologize. I will get it posted before this day is out. I will put it on Canvas and put a link on the main dash page. The main dashboard page. That's what I meant to say. You are correct. We can factor a 5 out. What do we leave behind in the wake of that?
A squared minus 4.
Thank you. Ladies and gentlemen, can we further factor the left side? Can this be further factored? You recognize it?
Yes.
It's a binomial. It's the difference between perfect what?
Squares.
Squares. 4 being a perfect square of what? 2? So how does this factor? How does a squared minus 4 factor? Difference between squares.
A plus 2, a minus 2.
Thank you. You got it. Now, ladies and gentlemen, we set our factors equal to 0, but I have a question for you. What factors do we set equal to 0? We only set what factors equal to 0? Variable factors. Do I set 5 equal to 0? Does it make sense to set 5 equal to 0?
No.
The only way this left side of this equation could ever be equal to 0 is not if 5 is equal to 0. 5 will never be 0. 5's 5. The only way this left side could ever be equal to 0 is if any of these variable factors are 0. So you only set the variable factors equal to 0. You don't worry about the 5. Then we just got 2 equations to solve. Subtracting 2 from both sides, one solution is -2. Adding 2 to both sides, we get another solution, which is +2. Some students think, wait a minute, what about the 5? Maybe is 5 one of our solutions? The answer is no. 5 is not a solution. Ladies and gentlemen, by factoring the 5 out of both these terms, that helped us to form the 2 solutions of -2 and 2. But 5 is not a solution to this equation. And don't set 5 equal to 0. It doesn't make sense to say so. We only have 2 solutions, -2 and +2. If you wanted to check your answers, you would see that they would have to check out. If you put -2 back in for A, does it work? 5 times 4 is 20. Is 20 minus 20 equal to 0? Does that work? That checks out. Put 2 back in for A. Does 2 check out? This is 4. 4 times 5 is 20. Is 20 minus 20 equal to 0? It checks out. Two solutions are -2 and 2. There you go. Make sense? All right.
Yes.
All right, I'm going to give you classwork number 1, ladies and gentlemen. I want you to try to solve some of these equations by factoring. Classwork 1. Today is the first day of December. You know, we only got about 3 weeks left of this class, and that is it. We are done. It's going to go fast. I know it sounds like an eternity. You'll see how fast those weeks go. All right, hang on tight. Ladies and gentlemen, I want you to try to solve some of these. Solve by factoring. Classwork 1. What are you going to have to do to number 3 first? What's the first thing you got to do with it?
Set it to 0.
Get it set equal to 0. Okay, go ahead and try those problems. I'm classwork number 1. See if you can solve all of those by factoring. Anybody get 2 and 3 for the first one? Anybody get 2 and 3 for solutions to the first one? Rebecca, did you get 2 and 3 for the first one? Sarah, did you get 2 and 3 for the first one?
I did not.
Okay, what did you get?
I kind of confused myself, so I didn't actually get that one done.
All right,
I was trying to figure it out.
you see it right there, the solution?
Yeah.
All right, did anybody get 2 and 3 out there?
Yeah.
Somebody did?
I did. I worked it out really long.
All right, but you did get 2 and 3?
Yes.
Okay. Now those would be the only solutions to that second degree equation. Let's try this one. Anybody get the solutions to this one? Anybody?
Yeah,
What'd you get?
I got t equals 8, t equals -8 for the second one.
For this one here? Okay.
Yeah,
It
All right.
has -8 and t +8.
Okay, -8, +8. Let me ask you this. Can we factor this left side? How does this left side factor?
you can pull a 4 out.
All right, when we factor a 4 out first, what do we leave behind?
T squared -16.
-16. Okay. Now, t squared -16 happens to be the difference between squares. 16 is a perfect square of what?
8.
Uh-oh.
One.
Is 8 times 8 16?
4. 4.
4. 16 is a perfect square of 4, not 8. So this
True.
factors into t -4 times t plus 4. Uh-oh. Yeah, it's not 8.
Nope.
It would be 8 if that was 64, but that's not 64 anymore. Okay, so anyways, you set your variable factors equal to 0. And you're going to have 2 solutions. And they're going to be +4 and -4, correct? And those would be your 2 solutions to that second degree equation. Finally, anybody have any success on this last one here?
I was still trying to work it out.
This one's a little bit more difficult. First, we have to zero the equation out by subtracting 4 from both sides. And then you got to try to factor this trinomial here. I'm going to give you a minute or so more to try to finish this problem, okay? So see if you can finish that problem there.
You leaving?
Yeah, I'm gonna shoot over there real quick to MD. I'll let him real quick and then dip off. Cause we gotta do that. Damn. I ain't gonna do that shit though. Doing that
All right, anybody get solutions to this last one here? How does this thing factor? Oh.
Grouping method.
Grouping. 6 times -4 is -24. Looks like 8 and what, -3. So this can be written as 6x squared plus 8x minus 3x minus 4. Use grouping. So we're going to try grouping on this. Factor out a 2x out of the first two terms, leaves behind 3x plus 4. Minus, you can factor a 1 out of the last two terms, 3x plus 4 left behind. Factor now the 3x plus 4 out since it's common to both terms. Times, that leaves behind 2x minus 1. Set both factors equal to 0, and you should get your solutions when you solve these equations. Solving this equation for x, we subtract 4 from both sides, and then we divide both sides by 3. And we get x is equal to 4/3. That's one solution. Setting this other factor equal to 0, solving for x, we add 1 to both sides. We get 2x equals 1. Divide both sides by 2, and another solution would be 1/2. Did anybody get these solutions here?
Is it 4/3 or -4/3?
Should be -4/3. Thank you. -4/3. So -4/3 and 1/2. Did we get these solutions?
Yes.
All right, nice job. Okay, this was factoring a difficult trinomial. That's why it took some time on this one. Okay, but nonetheless, that's our factorization skills coming back to visit us. And I think these were talked about in section what? 6.3 on my video I posted. How to factor the difficult types of trinomials by grouping method. Okay, make sure you watch that video if you haven't seen that already. All right, so we'll call that classwork number 1. Classwork 1. That's in the books now. All right, let's see what other kind of equations we have to solve here. All right, let's see here. Okay, let's give ourselves some weird looks now. All right, how do we solve this equation? By factoring. What do we have to do to this thing? First, you got to get the equation. Set equal to 0. And you want to factor the non-zero you want to factor completely the non-zero side. So how do I zero this equation out? How do I get 0 on the right side?
Would you add 25 to both sides?
Add 25 to both sides, and what else? How do you bring the 10x over to the left? How do you move a positive 10x to the other side of the equation?
Subtract it.
Subtract it. Let's just do one thing at a time though. Let's just subtract 10x from both sides first. That moves the 10x over to the left. 10x's drop out on the right side, leaving you with -25. Now, how do we move the -25 over to the left side?
Add it.
Add 25 to both sides. And when we do this, the right side of our equation goes to 0. And that's what we wanted. All right, now we got to try to factor this left side. Can I factor this trinomial? Notice there's nothing we can factor out of all 3 terms. What are 2 factors of +5 that add up to -10? What would they be? Two factors of 25 that sum up to -10.
5 times 5, -5 times 5.
-5 and -5. Hence, this trinomial factor is immediately in x minus 5 times x minus 5. Now, this is redundant because both factors are identical, so you don't have to set both of them equal to 0. Just set one of them equal to 0 and solve for x. We get x is equal to +5, and that would be it. Now, you're probably thinking, wait a minute, I thought that fundamental theorem of algebra guaranteed for a second-degree equation we're going to get two solutions. Well, we did get two solutions. It just so happens that these are repeated solutions. So we say x equals 5 is a repeated solution, repeats 2 times. Okay? So there really are two solutions. It's just that they're repeat solutions. Any questions about how we solve that one? Using the factoring technique. First, we had to get our equation set equal to 0. And then we went from there, ladies and gentlemen. Then we went from there. Okay. Any other questions on that one? Okay.
So it's only one solution?
No, there's two solutions. It's just that this is a repeated solution.
Oh, yeah, okay.
Or we would say x equals 5 with multiplicity of 2. That means this solution repeats itself 2 times, ladies and gentlemen. To even write this in more shorter notation, we would say the solution is x equals 5m2. M stands for the word multiplicity. 5 with multiplicity of 2, meaning it repeats 2 times, okay? You'll use this notation when you get into college algebra, math 130 here at Mott Community College, all righty? Any other questions on that problem? All right, let's see what else we got here. Hold on. There's got to be another problem in here somewhere. Oh, there is. How about this one? All right, what's weird about this problem? What's strange about it, ladies and gentlemen?
It's backwards.
It's kind of backwards, it's kind of flipped around. Normally, we always have 0 on the right side of our equation. You think it's going to be a problem to arrange for that to happen?
No.
What would I do to arrange for that to happen?
Would you just write it the opposite way?
Yeah, why not just flip the whole equation around? Why not just say 2 plus x minus 6x squared equals 0? What else is strange about this problem, though? There's something else. What's strange about it, ladies and gentlemen? What's weird?
It's not in descending order.
Yes, the left side is not written in descending order. Normally, we write polynomials in descending order. We can fix that too. Easy to fix. There we go. Now we need to solve this equation for x. Ladies and gentlemen, how am I going to factor this left side? How am I going to factor this left side? How do we factor that? Anybody?
Would you do the grouping method?
Yeah, I'm gonna have to use grouping. It looks like it's a nasty type of trinomial, difficult one. There's nothing we can factor out of all 3 terms. So yeah, here we go. -6 times 2 gives me a product of what? -12. And I need a sum of what? 1. Can you give me a couple factors of -12 that sum up to 1, ladies and gentlemen? The middle coefficient's 1. What factors would those be?
-3 and 4.
Nice job. You guys are getting good at this. -3 and 4. Boy, in the old days, we had to take a lot of time and list all our factors out. See, you're getting better at this. These things are just popping in your mind now. That means you are advancing, which is an awesome sign. Therefore, we can rewrite this as an equivalent 4-term polynomial now. The middle term, 1x, can be rewritten as negative 3x plus 4x. And now we will use grouping to take us the rest of the way. Group. Don't have to adjust the sign of the last term because we got a plus sign that precedes our third term here. First two terms, what can I factor out?
A 3.
You can factor a 3 out. Tell you what, I don't like all these
Yeah.
negative signs in here. Why don't we factor instead of a positive 3 out? How about we factor a what?
Negative 3.
Factor a negative 3 out. What's that going to leave behind? What am I going to leave behind?
Can
We
you factor
an
out?
X?
Yeah.
Oh, yeah, you got to factor an x out. So negative 3x. Thank you. What am I going to leave behind when I factor a negative 3x out?
2x minus 1
2x
plus 1.
plus 1. There we go. What can I factor out of the last two terms?
2.
2. And I better leave behind what binomial?
2x.
This one. Do I?
Yep.
It's like we do. Now we can factor that common binomial factor out of 2x plus 1 times, what do I leave behind after doing that? Negative 3x plus what? Plus 2. That left side, ladies and gentlemen, has been completely factored. Now we just set both factors equal to 0 and then solve for x to get our two solutions to this second degree equation. Solving this equation for x, we minus 1 from both sides, and we have 2x equals negative 1. Then we divide both sides by 2, and one solution walks out as being negative 1/2. That's one solution. Solving this equation for x, we subtract 2 from both sides, divide both sides by negative 3. And another solution is x equals what? 2/3? We're done. There's your two solutions. Negative 1/2 and 2/3. Questions, ladies and gentlemen, how we're doing this? All right, so that one's done.
Negative 2/3 or, oh no, it's positive. Okay.
It's positive 2/3. All right, that one is done. Okay, let's see, where are we with the clock? 6:02. All right, let's see what else we got here. Okay, let's give ourselves some even more different looks. Ladies and gentlemen, does this make any sense here? How we did that one? We good on that one? Okay, let's go on another one here. Let's give ourselves even more radical looks. Let's try this one. Want to solve this equation for x. I have a suggestion, excuse me, I have a question. What can we do first? Can anybody help me out? What would we do first here? I want to solve for x. You know, it looks like that left side is already factored. So does that mean I would set x equal to 12? And also set 3x minus 5 equal to 12? That would be absurd to even say that. Because if we said this, ladies and gentlemen, we would be saying that 12 times 12 equals 12. Is that true? Is 12 times 12, 12 times 12 equal to 12?
No.
Don't do that. The only time we set things, a variable factor is equal to something is when that something is what? 0. 0, that's not 0. Now, what do we have to do to solve this equation for x? Anybody?
Set it to 0.
Okay, we can get it set equal to 0. Even before we get it set equal to 0, can we simplify the left side at all? What property would enable me to remove the parentheses on the left side?
Distribute property.
Yeah, we really should distribute first. What's x times 3x? 3x squared? What's x times minus 5? Minus 5x equals 12. Ah, that looks a little bit more normal now, doesn't it? It is a second degree equation. It will have two solutions. We have to find the two solutions. So now we get our equation set equal to 0 by how? How do we drag this 12 over to the left algebraically?
Subtract it.
We got to minus it from both sides. And when we do that, we now are looking at this trinomial on the left side of our equation. Ladies and gentlemen, we have to try to factor this trinomial. I want everybody to try to factor that trinomial now. I'll give you a minute or so. Go ahead. All right, that left side factors like this, having used the grouping method. Set both factors equal to 0 now. And now we got two equations to solve. Solving the easy one first, adding 3 to both sides. We get a solution that says x is equal to 3. Solving the more difficult one. Subtract 4 from both sides first. Divide by 3. Another solution is -4/3. There you go, ladies and gentlemen. We got our two solutions, 3 and -4/3. So the first thing we had to do here is we had to distribute, multiply the left side out, 0 our equation out, and factor the left side. And then we went from there. Any questions how we just solved that equation? Okay. All right, get rid of that one there. Try another one here. All right, ladies, I want to solve for this equation for C. What do you think I would do here? Want to solve for C. Any ideas what I would have to do here?
I have two of the C plus 4s.
Yeah, we got to multiply C plus 4 by itself. So C plus 4 times C plus 4. We have to FOIL this out on the left side of our equation then. Don't have any choice but to do so. So C times C, C squared. C times 4 plus 4C. 4 times C plus 4C. 4 times 4 plus 16. Gather like terms on the left side of our equation. 4C plus 4C combined to give you 8C. What's the next step now?
You got to get C plus 6 on the left side.
Okay, so we got to zero our equation out, get a set equal to 0. The only way we're going to accomplish that is by moving a 1C to the left and a plus 6 to the left. The only way we're going to accomplish that is by subtracting C from both sides and also subtracting 6 from both sides. When we do that, 8C minus 1C is combined to give you 7C. 16 minus 6 combined to give you 10. And on the right side of our equation, the whole right side goes to 0. All right. Now can we factor this trinomial on the left side of our equation? How would that factor? That's an easy type to factor. We do not need to use grouping on this one. What are two factors of 10 that add up to 7?
5 and 2.
2 and what?
5.
2 and 5 are the only factors of 10 that sum up to 7. Hence, this trinomial factors immediately into C plus 2 times C plus 5. Set the factors equal to 0 now and solve your equations. Subtracting 2 from both sides to solve this equation for C, we get -2 as being one solution. Subtracting 5 from both sides of this equation, we get another solution that is what? -5. Ladies and gentlemen, we are done. We have our two solutions to that quadratic or second degree equation. Okay. That is a second degree equation, and we got two solutions, and we're done with that problem. Any questions about that one? Okay. All right, let's try this one. Ladies and gentlemen, help me solve this equation for C. What's the degree of this equation?
Fourth,
What degree?
the fourth.
The fourth degree equation. How many solutions is it going to have?
4.
There must be 4 solutions according to the fundamental theorem of algebra. How are we going to find these 4 solutions? What do we got to do? We got to get the equation set equal to what?
0.
How do we get it set equal to 0?
Subtract 81.
Let's minus off 81 from both sides. And when we do that, we will have our equation set equal to 0. And now, ladies and gentlemen, help me factor this left side. Go back to chapter 6, our factoring skills. What do we got here? Binomial. Might it be the difference of cubes or squares? What do you think?
Squares.
Squares. It's the difference of squares. So it should factor into the product of conjugate binomials. What would those be? What do you square to get c to the 4th?
C squared.
C squared. Isn't that true? So I'm going to see c to the 4th minus 81 is going to factor into c squared plus 9 times c squared what?
Minus
Minus 9. Okay. Can we further factor this down?
Yes.
This is the sum of squares, which cannot be further factored down, but we can factor this down. Being the difference of squares again, it can further factor down into what?
C minus 3, C plus 3.
So that factors. All right. We set all our variable factors equal to 0. Solving this equation for c by adding 3 to both sides, we get 3 for one solution. Subtracting 3 from both sides, we get a solution of -3. This equation here, ladies and gentlemen, we're not ready to solve. We haven't seen one like this before. We cannot factor this left side. This equation would generate 2 solutions, but they're going to be 2 non-real solutions. 2 non-real solutions. So I'm just going to leave this problem as this. I won't give you one like this on a quiz or exam, but this would give you 2 what are called complex or imaginary solutions. So there would be 2 solutions for this guy, 3, 4 solutions total. Okay. All right. I just want to throw that one out like that, but I won't give you one like that in an exam though, because we don't know. We're not prepared to solve something like this. All right. This is a hint of things to come if you go into intermediate algebra or college algebra. All right. You'll run into something.
No.
You'll be able to solve something like this though. Isn't that amazing? You got better, more beautiful things coming your way in algebra. You know? And it's going to get more and more beautiful the further you go in mathematics.
Be crying.
Right.
Crying? Oh, I thought those were tears of elation. Okay.
Heck
They're
no.
tears of sorrow. Sorry to hear about that. I thought our journey was going so well in math here. All right, we won't dabble with that one anymore. We'll put that one away. All right. Forget that one. Let's try this one. 24x cubed minus 22x squared equals -4x. How would we solve this equation? And how many solutions are we going to have to this equation when we get done? What do you think?
3.
There will be 3 solutions. It is a 3rd degree polynomial equation. Now, how are we going to start to move in the direction of getting these solutions? Get me started here.
Add 4x to both sides.
We got to zero this equation out. So we got to add 4x to both sides to bring this 4x over to the left. Let's do that first. Add 4x to the left, add 4x to the right. The left side, therefore, looks like this. All right. Now, can we factor this left side in any way?
Yes.
What can I factor out of all 3 terms?
4.
Not a 4, but at least a what? 2.
Yeah.
And what else? 2x. Yeah, what do we leave behind?
12x squared minus
12x squared
11x
minus 11x
plus 2.
plus 2. Now we have the unenviable task of trying to factor a difficult type of trinomial, one that's probably going to need grouping. Hence, I'm going to drag this off the side of my paper. I will wrestle with it and factor it. Then I'll bring the factorization back to my main problem, ladies and gentlemen. So let's take this trinomial off to the side and try to factor it on its own accord. To do so, grouping. 12 times 2 gives me a product of what?
24.
And I need a sum of what?
11.
Negative 11. Can you find for me a couple of factors of 24 that add up, sum up to negative 11, the middle coefficient? Well, got to list the negative factors since they have to add up to a negative. Which ones sum up to negative 11?
Three.
Negative 3 and negative 8 are the only ones that work. Hence, we're now going to rewrite this trinomial as an equivalent 4-term polynomial. Our middle term gets split up and then rewritten in terms of the sum of negative 3x minus 8x. Now I will factor this via what? Grouping. Got to adjust the sign of the last term because we got that minus sign in front of the third term. Don't forget that. What can I factor out of the first two terms?
Three x
Times, what do I leave behind?
4x minus 1.
Good. What can I factor out of the last two terms? Hoping to leave this behind.
2.
2, and I leave behind 4x minus 1. Looks good. Now we factor out the common binomial factor, 4x minus 1 times what do I leave left in doing that?
3x minus 2.
3x minus 2. Ladies and gentlemen, that's the factorization of this difficult trinomial. Let's bring this factorization back to my main problem. Bring it back to the main problem here now. Let's now set all our variable factors equal to 0. That means we got to set 2x, 4x minus 1, and 3x minus 2 all equal to 0. When we set this equal to 0 and solve for x by dividing both sides by 2, we get one solution as being 0. There's one solution. Setting the other factor equal to 0, which is to say we set 4x minus 1 equal to 0. Solving for x, we add 1 to both sides. We get 4x equals 1, divide both sides by 4. And this implies that another solution is going to be 1/4. Setting the third factor, 3x minus 2 equal to 0, solving for x. Adding 2 to both sides, we get 3x equals 2. Divide both sides by 3, and our third solution is going to be 2/3. We have our three solutions to our third degree equation. They are what? 0, 1/4, and what? 2/3. Does that make sense how we solve that third degree equation by using our factoring method? That makes sense, ladies and gentlemen, what just happened there?
Yes.
All right. I'm going to give you classwork number 2 now. This is the final classwork tonight, ladies and gentlemen. See if you can do something with it. I want you to solve these equations. Solve by factoring. All right, problem number 1. Here's number one. Number two. Number two. And number three. There you go, ladies and gentlemen. We'll call that class the final classwork tonight. See if you can maybe solve those equations there. Anybody get the first one correct and feel confident?
No, I didn't get the answer, but I started the equation though.
All right.
I tried to start, I did not define with this at all.
Yeah, started it.
All right, well, let's take a look at it here. All right, so the first one, you got to factor out 2x first, and then you're gonna have to factor this difficult trinomial, and it will factor like this eventually using your grouping method. And if you wanted to see that grouping method, let's see. 4 times -5 is -20. 2 factors of -20 to sum up to 8 would be 10 and -2. So this can be the trinomial can be rewritten as 4x squared plus 10x minus 2x minus 5. Then we group. Factor out 2x.
Your page is cut off a little bit.
Yeah. Factor out the 2x plus 5 now. So that's how this factors, and you can see the factorization. Then you set your factors equal to 0 and solve all 3 equations, and those would be your solutions. 3 solutions to a 3rd degree equation.
I messed up because I wrote it wrong.
Okay. Oh yeah, that'll do it. All right, the second equation here, second problem, you gotta, multiply this x in here on the left side, subtract 32 from both sides, zero your equation out, and then just rearrange these terms to get this in descending order. What I did is I multiplied both sides of the equation by -1 to get rid of the leading negative sign here. 2 factors of 32 that add up to -12 be -4 and -8. And so then that trinomial factors like this, and then you set your factors equal to 0 to find the x. Your 2 solutions be 4 and 8. All right, so that's that. The last problem, let me know if anybody's ready to look at the last one. We good on these first 2 or not?
Yeah.
All right, the last one's right here. You got to multiply this left side out. Got to bring the y over to the left and the 4 over to the left by subtracting y and adding 4 to both sides. Combining like terms, this trinomial has to be factored then into y minus 5 times y minus 8. And then we set these factors equal to 0, solve for y, we get 5 and 8 for the solutions. All right. And there you have it, ladies and gentlemen. That's the last classwork for tonight. So what we've discovered in section 7. In the last section 6.6 here tonight, as we close the door on chapter 6, is how to use our factoring skills to solve higher degree polynomial equations. And so that is the end of this chapter. And next week we'll begin chapter 7. We only have about 3 weeks left in this class. We just have chapter 7 to go through. And maybe a section or 2 out of 8, and that's pretty much it. We're gonna close the door on math 082. So we're in the home stretch here now. Oh, another thing is, I think I have to make a quiz available for you, don't I? Looks like the chapter, 6 quiz? I will eventually get the chapter 6 quiz available for you. And I will indicate via email when I want you to turn that chapter 6 quiz in, okay? So stay tuned on that one, ladies and gentlemen. I will let you go. Hopefully you have a good weekend. I'll see you next week. But I will get the chapter 6 quiz to you and indicate a due date on that, all righty?
In the toolbox.
And the factoring toolbox, you are correct. Oh, and I also have to get the chapter 5 and 6 exam to you and indicate a due date. I will get all that to you, and please do check your email on a regular basis so that you can stay abreast of important information that I relay, okay, about due dates. All right, I will let you go. You guys have a great weekend. Take care.
You too. Thank you. Mm, mm.